In this tutorial, I will show how to select different regions of interest of a FLIM image and how to analyze them to obtain their lifetimes. As an example, I will use a FLIM image of daisy pollen. So the first thing is to open the workspace where we have the data, highlight it, go to Analysis, Imaging, and go to FLIM. So we see that the analysis window had different parts. At the left, we've got the analysis options. In the center, we've got the FLIM image and the tools to play with the FLIM contrast and the intensity contrast. At the right, we've got the lifetime histogram. And at the bottom, we've got the time corrected single photon counted histogram of the whole image and also the parameters for the exponential fittings. So the first thing is to play with the contrast to try to get the best FLIM contrast as possible. And for this sample, I know that it works very well between 0.7 nanoseconds and 2 nanoseconds. So to select regions of interest, I go to right click and then I select the different ROI options. For example, I will go free ROI and I will select this outer structure of the daisy pollen, so the shell. When I activate it, I see that the histogram is in the TC-specific window and is named as ROI 0. If I want to keep on adding regions of interest, I go to New. And now I will select, for example, a rectangular ROI in a different region, like here in the green region, for example. And we see that the corresponding histogram is also appearing in the window now. It's named as ROI 1. And now my aim will be those little red spots, and for this I will use a different tool that is called Magic 1 ROI. And when selected, it looks for pixels in the vicinity with similar lifetimes and intensity. A good trick to select them all is just to, instead of to keep on adding them within a row, is to delete them. For this I have to click Hold and Control and then perform an inverted ROI. So I click to all of them with the Magic 1. Put Hold and Control. And now I perform an invert ROI. So we've got now here the histogram also in the window and named as ROI 2. And now if I want to see and visualize again the different regions of interest, I can scroll through them here. So I want to do the fittings now, and the software gives us the choice to make exponential tail fit or a convolution fit. So I will pick the ROI number 2. I will pick the ROI number 0 and I will attempt with the reconvolution fitting. The IREF is generated by the software and we're going to look what the equations look like for reconvolution fitting. We can click Help or press F1. So we'll first start with one single exponential decay and we see that the fit is very bad. There are strong deviations between the experimental data and the generated single exponential function. So I will try with 2. And the fit looks better, but still the chi-square is a little bit high, it's 1.4, and we still have deviations in the tail of the decay. So I will try with 3. And now we've got almost perfect distribution of the residuals, around 0, and a very good chi value, close to 1.1. If I do it with 4, I will see that the fitting does not improve significantly. So the chi-square remains the same, and the residuals also remains very similar. On top, the exponential factor of the fourth exponential term has negative value. This means a rising component and does not make sense for this sample. So we'll keep it to 3 and I will click Initial Fit again. I can also go to Fit All And then what will happen is the software will perform a fitting of all those data sets to 3 exponentials. So we've got the 3 regions of interest that we have selected, we've got the overall decay, and also 1 pixel that in this case is the 1, 1. This could also be, we could have also picked a different one. So if we want to view the parameters, we can go to parameter plot and represent the parameters we want to display. For example, I will go to the average lifetimes, weighted by the intensity, and we have them here. So we've got it. We've got 5 data sheets which corresponds to the 3 ROIs of interest, the whole image, and also the pixel at position 1, 1. It is possible to export this to save the data in Notepad, for example, or in other programs. So we go to right click and export as the all cells, so all the parameters. And I will save it as results. And when I open it, I will see that I've got all the results saved here. So the 3 per exponential factors, the 3 lifetimes, the shift, the background, the intensities, and so on and so forth. A good habit is to rename those data sets so we remember what they are and we do not get confused. So ROI 0, ROI 1, and ROI 2. The first one is the overall decay, and the second one is the pixel. In this case, the pixel at position 1, 1. So we'll save it and close it. And now I can save all the results. And when we do this, we generate an additional file which has the extension PQRes, which stands for results.